Okay, I'm going to go through a quick presentation of color theory, intro to color. Here's an image by Claude Monet. We're going to talk about the attributes of color, and you'll do a kind of a draw along with a couple of assignments on this PowerPoint also. Okay. On this image, the brightest thing on this image, the thing that catches your attention most, is the sun, right? However, the sun is not the lightest object in this painting. You can find the lightest objects, the lightest values, either in the reflection down near the bottom of the painting or right near the very tippy top of the painting. Those are the lightest values on your value scale. However, the sun looks like it could be just as light as that because it is very saturated, whereas the rest of the image are more muted in color. Okay. Color has value, saturation, or intensity is another way of saying that, and hue. So we'll talk about that. What is color? Essentially, it's light waves, either from a light source directly or when it is reflected off of objects in the form of light waves. The resonant frequencies of the molecules in objects either cause light photons to bounce off or be absorbed by the object. The frequency of the wave that gets bounced back into our eye is what's translated into color. It's a perception that happens entirely inside of our brain. Our eyes are receptors that pick up these different frequencies, but it is our brain that interprets them into different colors. Here's some terms that you can review to help you understand just the very beginning, maybe a 101 course on how light operates and how color operates. Okay. Different materials have different natural frequencies that either absorb or emit radiation or light. Okay. If the frequency of an object, that's kind of like the vibration of an object, okay, matches the vibration or the frequency of the light that's hitting it, then it's absorbed. Otherwise, it bounces off the surface of it. And it's only because of that reflection, because of that bouncing of light, that we see anything at all. Here's just a quick glance at light spectrum. We've got all sorts of light here: radio, microwave, infrared, UV, X-ray, gamma. These all sound like scientific terms. Maybe they show up in movies or whatnot. We have ways of seeing these frequencies of light, but we have to use special tools to do that. And those special tools translate the really long or really short frequencies that we normally can't see into something that we can see by changing them into the visible light spectrum. You can see right here in the middle, this teeny tiny portion right here represents the visible light to humans, which is almost nothing. We are surrounded by color constantly that is completely invisible to us. Color is subjective to a degree. It can vary from person to person based off of genetics in terms of their rods and cones and the receptors in their eyes, or neurological functions inside the brain. Okay, so this is an example here of how different people might perceive the same thing. We have ways of testing color blindness. However, it's very subjective. We don't have a very accurate way of depicting exactly what is being seen by somebody. We know when something is absent in terms of receptors, but it's hard to determine exactly how they are seeing. Color blindness is very, very common, and it comes in degrees. It is much more common in men. It's very common in men. So color, the phenomena of color, is a combination of stimuli that's coming from the outside world through light and photons and different frequencies that make their way through the pupil of our eye into the back of our eyes, where the rods and cones interpret them into an electrical signal, which is then processed in the brain. Okay? So color is actually happening inside your brain, which is why if you've ever been binged up the side of the head with a baseball bat or hit really hard, you actually can see things, stars, light. It's because your brain is sending out impulses that are being interpreted as color. There are other things that can cause you to see things also, even things that aren't there, hallucinogenics, etc. When you mess up the functions of the brain, either through physical abuse or otherwise, it can also alter your perception. Okay? So, fun activity is, if you would please visit either this website or any other, you can just Google color blindness test. I want you to try out a few of those. Maybe test your friends and determine if somebody has a variation of color blindness. Again, it comes in degrees. Okay? So give that a test, pause the video, and then come back. In painting, when you're mixing paint, what you're actually doing is changing the chemical composition of the material, the paint, so that light bounces off it in a different way than it did when it was separate. Artists use this as a means of communication. We associate color with different feelings. How you use your colors will determine what sort of message that you are portraying. This pink room is not from a Malibu Barbie house. Okay, it's from a penitentiary, and it is used to calm down inmates that are out of control. Pink can have a soothing effect. It can also have an agitating effect if somebody is left in there for too long of a period. Can you think of any other colors that are used to try to manipulate your feelings or emotions? Some other examples that I can think of would be restaurants. Think of how many restaurants you can think of that use the color red or yellow in their advertisements or in their interior design. There are plenty of studies that show that color can even affect appetite. That's just an intro to color psychology. We may cover some more of that in the future. Color has three different qualities. Okay, when we say color, we're actually talking about three different things. One is hue, which is normally what we mean when we say color. Hue is red, orange, yellow, green, blue, purple. Okay? But on top of hue, all color has value. All color is a certain variation of lightness or darkness applied to it. There's light blue, there's dark blue, okay? And then we come up with great names for all of them: midnight blue, eggshell blue, but they're all describing a couple of different characteristics. One is the hue, one is the value, and the last one is the intensity of that color or the saturation. Okay? The eggshell blue is a very muted or not saturated color. It's very pale compared to, say, a clown's nose, which is typically a very saturated red. Hue, value, and saturation. Let me say that one more time because it's very important. Color has 3 dimensions: hue, value, and saturation. Okay, hue, just a pure color. Here's your color wheel. You should become very, very, very familiar with your color wheel. It's great for organizing your color and creating color schematics for your paintings. We've known this, we've done this since we were very young. We should know that our primary colors and our secondary colors by now. A color wheel organizes them in a way that is very useful. The primary colors are 1, 2, 3, red, yellow, and blue, right? These colors cannot be created by mixing other colors. You have to start with a red pigment, a yellow pigment, or a blue pigment. There's not a way to combine other colors to get them. All of the other colors on the color wheel are used by making a combination of these. They are equally spaced out on the color wheel. Your secondary colors are a combination of your primary colors. This should be very obvious and well known to you by now. Red and yellow make orange, yellow and blue make green, blue and red make purple or violet. Tertiary colors are the colors that are in between your primaries and secondaries. That means they're a combination of one primary color and one secondary color. These are your colors like yellow-orange, yellow-green, blue-green. Okay? Sometimes we have other names for them like teal or tangerine, but they are the colors in between a primary and a secondary. When you paint, it's always important to have your paint station set up with paper towels, your palette, a water container, a ground, which is your color wheel, okay, and have everything easily accessible. Make sure that you treat your brushes correctly. Only use the tip of the brush. You never want to munch them, ever. You don't want to get paint in the bristles like is shown in the bottom picture. That will ruin them. It's very difficult to get paint out of the base of the brushes. Okay? When you're cleaning, you need to open your bristles up, make sure that the paint is entirely out of it, and you should clean your palette. You should only ever mix your colors in the palette. You should never mix your colors within the pigments themselves. That will taint the pigments and it will ruin the color purity of them. And you need those to stay standard. Do all of your mixing separate on your palette or the tray in the case of watercolor above. Here's your procedures for cleanup. As we mentioned before, all color has value or lightness and darkness. This little graph basically gives you an idea of how a color, even a bright color like yellow, also has a lightness or darkness assigned to it. If you squint your eyes at it, sometimes it helps, but you can see that that top gray box is basically the same amount of lightness or darkness as the yellow, the difference being that the yellow is very, very saturated, whereas the gray has no saturation at all. The equivalent of that value is also shown in the pink to the right. Okay, those are all basically the same. It can be difficult to attain the correct value of a color just by looking at a supersaturated color. It takes practice. It's much easier to find the value when a color is muted, but all color also has value. Tints are when you add white to a painting or to your paint. When you use watercolor, you're using the white of the paper actually as a mixing agent to get your tints. Tones, you add gray, and shades are when you add black. It is not recommended. Many painters do not recommend using straight black to shade your paint because it dilutes the purity of the color. You can also use the opposite color in small doses to darken whatever color that you're working with. That means being familiar with your color wheel. For example, if you're using red and you need a darker red than you have, you can add a very small amount of green into your red and it will continue to be red but a much darker value of it. Value is arguably much more important than color in painting. These paintings here are monochromatic, but because the values are accurate, it is very clear and distinct what it is that they are portraying. If you totally nail the value of a particular part of an object, then the color will also appear to make sense. The intensity of an object. Fuchsia is a very bright, saturated color, whereas olive is a low intensity color. Here are some examples of more neutral colors. If you mix opposite colors in basically equal parts, you're going to come up with a very neutral color between the two. Neutralized colors are good. Most colors that we see are not super saturated. Warm tones are on this side of the color wheel. They're reds, yellows, and oranges. And cool tones on the other side of the spectrum. A monochromatic color scheme is using all different values and shades and tints of a singular color. Analogous color schemes are colors that are next to each other on the color wheel. Complementary color schemes are opposite on the color wheel. Split complementary color schemes are almost opposite. It's the two colors next to the opposite color on a color wheel. Triadic color schematics are colors that are evenly spaced on the color wheel. That concludes our introduction to color.